So when we have this joint event, it just means that either one event could occur or the other event could occur, but it's impossible for both events to occur at the same time. So some example of a disjoint event, say if we're flipping a coin, is it possible for the coin to land on tail and head? So that would be a disjoint event. A coin flip, because a coin flip is either gonna land on head or it's gonna land on tail. Another disjoint event, say if we wanted to know if you drive, this is going to be a disjoint event because either you're going to tell me yes, you do drive, or you're going to tell me no, you don't drive. So whenever we're talking about disjoint event, you're either is two events that cannot occur at the same time. You're going to fall under one of them, but you can't fall under both of those categories. So, any question in regard to that so far? Actually. So we're going to get into this symbol right here. This symbol represents OR. So OR usually represents a union. So whenever we're finding an OR statement, you just want to add up the probability. So if you look at this one, it says probability of A or B. So to find the probability of A or B, what you have to do, you have to find the probability of A, you have to find the probability of B, and you have to add up the two factors.
Okay.
Everybody good so far with that logic?
Yeah.
Cool.
Yeah.
So let's scroll down and let's do this first problem. So this one says the first digit of a number is in legitimate financial record often follow a model known as Benford law. Call the first digit of the randomly chosen record X. Benford law gives the following probability model for X. So for this one, it's telling us the first digit could be 1, the first digit could be 2, the first digit could be 3, so on and so forth. So if you look at this, this is a disjoint event because it's not possible for the first digit to be a 1 and a 3. It's either going to be 1 or it'll be a different number. So it's a disjoint event.
Okay.
So if you look at part A, it says show that this is a legitimate probability. Does anybody remember the two conditions for to check to see if something is a probability model? Well, one of the probability condition is that it has to be between 0 and 1.
Oh, okay, okay.
Does anybody know the second one?
No.
Well, the second one is that if you add up all the probability, it should always add up to 1.
Okay.
So what we're going to do right now, we're going to check to see if that's true. So what we're going to do, we're going to look at all of these probability right here. And we want to see, are all of these probability between 0 and 1?
Okay.
So are all of the numbers that I just highlighted, are they between 0 and 1?
Yes.
Cool. So we'll check this one off. All right. So how can I check out the second one?
You add them up?
Yeah, let's add them up. So I'm going to get my calculator over here. Let me turn on the calculator. And let's add them up. So we'll say 0.30. Oops. Didn't put the 1. Plus 0.176 plus All right, so I think I got all the number, and if you look at it, it does add up to 1, so that checked off.
Oh, okay, yay, cool.
Cool. All right, so we'll say this is a probability model. All right. And that's all A is asking for. Any question for A? If you do have a question, you can just post that on chat, or if you want to be vocal, you can just say your name and you tell me you have a question. All right, cool. So let's go to part B. So if you look at part B, it says find the probability that the first digit for the chosen number is 3 or 7. So we're saying it could either be a 3 or it could be a 7. So those are our two options. And this one, the key word that I know we're doing an OR statement, if you look at it, is the OR right here.
Mm-hmm.
So that's telling me that's the reason why we're using this model. So first thing I'm going to go ahead and do, get the probability of 3, which probability of 3 is right over here, is 0.125. Now what we want to do, we want to find the probability of 7, which is right over here, which is plus 0.058. So I'm going to add those two up, and that'll be it for that one. So say 0.125 plus 0.058. We add them up, and we get 0.183. And that's it for B. Any question for B?
No, you just basically add them.
Yeah. All right, so let's move on up. Let's go to C. So for C, it said what the probability of the first digit for the chosen number is not 8. All right, so this one's a little bit different. Because pretty much we just want it to not be 8.
Okay.
Cool. So if I want it not to be, well, sorry, not to be 9, pretty much we want all of these. But the thing, so there's two ways that you can go about this problem. You can actually add up all of those numbers, or what you could do, you could use something called a complement rule. So the complement rule just pretty much says you do 1 minus the probability that you don't want.
Mm-hmm.
And that will give you the probability that you want. All right. So what's the probability that I don't want?
9.
None.
Oh, 0.046, I guess.
Yeah. So we could say 0.046. And why do we think we have that 1 over here? Well,
because for the model, everything added up to 1.
Perfect, because if this is a probability model, it always has to add up to 1. So if I want to find, since I already know all of this together add up to 1, I can do 1 minus the probability I don't want, and I know it will give me the pretty much the probability I do want. So we're going to just do this subtraction, and we'll be done. So say 1 minus 0.046. And you get 0.954. And that's it for C. Any question for C?
No?
So let's scroll on down. So for 12.6, we're going to start dealing with continuous probability model. So far we've been dealing with discrete model. For continuous probability model, it just means that we can't find the probability of one event occurring, because the probability of one event occurring is essentially going to be 0. You always have to find the probability of an area occurring. So right now we're going to do something called a uniform distribution. So for a uniform distribution, it's always going to have a square or a rectangular shape. Because for a uniform distribution, it's saying all outcomes are equally likely. So if I were to divide this into equal spaces or equal area, pretty much area A, area B, and area C, and area D will all equal the same thing, because as long as they cover the same area, it will be the same probability. So that's one of the unique things for a uniform distribution, is saying all outcomes are equally likely. So say if I wanted to find the probability of A occurring, if you look at A, how many total rectangles are inside this big rectangle?
4.
Yeah, 4. And how much well, if you look at A, how many rectangle are shaded?
1.
Cool. Oops, sorry. Did not want to zoom in. So you get 1 out of 4. And if you look at B, B will also be 1 out of 4. C will be 1 out of 4. D will also be 1 out of 4. Because all 4 of them are equally likely to occur.
Okay.
Everybody so far go with that? Cool. All right. So let's kind of get into the problem, and then I'll tell you about the formula. Let me erase this for you. So for this one, said the cable company said they will be at your house to fix the cable between 9 a.m. to 3 p.m. It is equally likely that the cable man will arrive from 10 to 11 a.m. than if it will arrive from 2 to 3 p.m. So it says, what if the probability the cable man come after 1 p.m. assuming X has a uniform probability distribution? So for this one, there's one very important word that they tell you, and the important word that they give you is uniform. Because in order for you to know you have to do a uniform distribution, they actually have to tell you it's a uniform distribution or that it follow a uniform distribution. So say like on a quiz or on a test, in order for you to do what I'm about to do, I have to tell you the uniform distribution. If I don't tell you the uniform distribution, then there's going to be another way that you can find the probability. But this only works if I tell you the uniform distribution. Everybody kind of good with that? All right. So we're going to go ahead and we're going to draw a box. All right. So what's the earliest time that the cable guy could arrive? If you want, you can either put it on the chat, or if you want, you can just shout it out.
9 a.m.
There you go. Sorry about that. Yeah, so the earliest the cable guy could arrive is 9 a.m. What's the latest the cable guy could arrive?
3 p.m.
3 p.m. Perfect. All right. Everybody good? Well, we got 9 a.m. as the earliest time and 3 p.m. as the latest time. So usually when you're using time, you don't want to use time because time tends to like reset. Like at 12 o'clock, it will go back to 1, 2, 3. So you don't really want to use time. What we're gonna do, we're gonna say how much time have the person waited. So say if the cable guy arrived at exactly 9 a.m., how much time did the person wait for?
mm,
So if they tell you you're gonna wait from 9 a.m. to 3 p.m., but the cable guy arrived exactly at 9 a.m., how much time did we wait for?
no time?
No time. So how can I say no time as a number?
0?
0.
0. Perfect. So say now the cable guy arrived all the way until 3 p.m. How many hours did we wait for the cable guy?
4 hours.
How many hours?
6.
There you
7? Oh shit, no. Sorry.
go. No, it should be 6.
Okay.
If you do 10, 11, 12, 1, 2, 3, it will be 6.
Okay.
All right. Everybody go with 0 to 6. All right. So if you look right here, it says we want to find the probability that the cable man come after 1 p.m. So 1 p.m. we're gonna say it's somewhere over here. So that's 1 p.m. So we'll put a little bar right here. So if we want him to come after 1 p.m., should I say the left side or should I say the right side?
Right.
Yeah, good. Everybody good? Why we shaded the right side?
Yes.
Okay. So if the cable guy arrived at 1 p.m., how long did we wait for? So how many hours did we wait?
4
Yeah,
hours.
4. Good, Naomi. 4 hours. Okay. Everybody get where that 4 come from?
Yes.
Okay. So here comes the important stuff. You want to find this probability. So we want to find this probability. So when you took a basic class or basic algebra class, you should have gone over an area of a rectangle. What's the formula for the area of a rectangle?
Base times height.
Perfect. Cool. Base times height. So that's what we're going to use. So what we're going to try to do, we're going to find the area of the yellow shaded rectangle by finding the base and finding the height of it. So first let's find the base. So the base will be here. So from 1 p.m. to 3 p.m., how much did they wait for?
2.
Yeah, 2. Also, if you look at it, if you would have done 6 minus 4, you get 2 again. All right. Everybody good so far with this? All right. So up next, we're going to get the height of the uniform distribution. So to get the height of the uniform distribution, we're actually going to be using this formula over here. So B will be the highest number. A will be the lowest. So A will represent the lowest number, which is here, which is 0. B will represent the highest number, which is 6. So let's find that. So we're going to say 1 divided by 6 minus 0, which is 1 over 6. Any questions so far? I got the 1 out of 6. Okay. So I know the height now is 1 out of 6. I know the base is 2. So all we're going to do, we're going to say base, which is 2, multiplied by height, which is 1 out of 6, which is equal to 2 out of 6, which, if you convert that to a percentage, is 33.3%. And that's our answer. So our answer for what's the probability that will wait after 1 p.m. or the cable guy will come after 1 p.m. we'll say is a 33.3% chance that will occur. Any question in regard to this first problem for uniform distribution?
No.
No.
All right. So let's move on down, and we're gonna do another one. So for this one, said the manager of a local soft drink bottling company believes that when a new beverage dispensing machine is set to dispense 7 ounce, it in fact dispense a amount X at a random answer between, or a random anywhere between 6.5 and 7.5 ounces inclusive. Suppose X has a uniform probability distribution. So first off, what is the keyword that they give us here that let us know that we want to use a uniform distribution?
The word uniform.
Yeah, the word uniform. All right, so on the chat, what I want you to do, you type in what the lowest amount that they could possibly get for a soft drink or will be dispensed for a soft drink. And let me just draw this out. There you go, 6.5. Thank you, Karen. What's the highest amount that will be dispensed by this soda machine or beverage machine? Yeah, 7.5. Thank you, Brian. All right. Everybody good with 6.5 to 7.5?
Yes.
All right. So up next, what we're going to do, we're going to get the height. So for the height, we do 1 divided by the biggest number. So the biggest number right here is 7.5. And the lowest number is 6.5. So what's 7.5 minus 6.5?
1.
There you go. So you get 1 divided by 1. 1 divided by 1 is 1. So that means the height is 1. Any question on how we get the height is 1?
No.
All right, so let's go on, and now we're going to look at what is the problem asking us to find. So it says, what are the probability that for a randomly selected bottle, the machine will dispense at least 6.75? So we're going to say 6.75 is somewhere over here. So there's 6.75. So for this one, do we want to shade the left side or should we shade the right side? And if you want the chat, you can either type in left or you can either type in right or LR.
Left.
All right. Well, for this one, you kind of want to look at the keyword at least. If you remember, the word at least means that that's the minimum. So tell me, the minimum, it could be 6.75, but it's okay if it's anything above 6.75.
Oh, so that means the right's gonna be shaded?
Correct. The right side should be shaded.
Because the least you could get is 6.5. Therefore, we can't go any lower than that.
Perfect. Yeah. So just telling you the lowest it could be is 6.75, but it could be any value above it. All right. Everybody good so far? What do you say the right hand side now?
Yes.
So far, what we want to go ahead and do, we want to go ahead and find the base. So we want to look from 6.75 to 7.5. What's the difference? So to do that, we're going to do 7.5. So that's the highest value we have. And then the minimum that we want is 6.75. And I'm going to do that over here with my calculator. So we'll turn it on. We'll do 7.5 minus 6.75. And we get 0.75. So this is 0.75. Any questions so far where the 0.75 come from?
No.
So I found my base to be 0.75. I found my height to be 1. What should I do with those two numbers?
Multiply.
Yeah, multiply. So we'll say 0.75 multiplied by 1. And shocker, you get 0.75. So you get 75%. And that's it.
Okay.
Everybody good for A?
Yes.
All right. So let me do B. So for B, it says, what are the probability that for a randomly selected bottle, the machine would dispense more than 7.25 ounces? So let me draw this again. So here goes 6.5. Here goes 7.5. Here goes 7.25. So if we wanted to dispense more than 7.25, which side should I take? The left side, which is over here, or the right side? Right. Thank you, Karen. So it should be the right-hand side. So over here, the keyword is more than. So more than means the right-hand side.
Okay.
Everybody good with that so far?
Yes.
Okay. So from 7.25 all the way to 7.5, what's the distance between 7.25 to 7.5? And if you want, you can type it in to the chat. Cool. Thank you, Karen. So it should be 0.25. So I know the base is 0.25 and I know the height is 1. So all you have to do is do 1 multiplied by 0.25 and you get 25%. And you're done.
Nice.
Any question for B? All right, so what I want you to do, I want you to practice on the next problem. So I'll put up a poll and I'll give you some options on what the answer could be. So A, all right. So I want you to work on it. Once you're done working on it, just type in your answer onto the poll. So you tell me A is 33.3%, B is 20%, C is 16.6%, or D is 50%.
Mm,
Alright, so let's try doing this problem. So far we have A with 0 people choosing A. 1 person chose B. 7 people chose C. 0 people chose D. So let's see which of these 3 options should we choose. Should we choose A, B, or C to shade? Should I shade A in? Should I shade B in? Or should I shade C in?
B.
Yeah, so you want to shade B in. Cool. So we want to find the area of that pretty much part B. So what we want to do, first thing we're going to do, we're going to get the height of this. So to get the height of it, let me erase something. So we want to get the height of this rectangular figure. So we want to do 1 divided by the highest number. What's the highest number?
30.
Yeah. What's the lowest number?
0.
Cool. So you get 1 divided by 30. So that's the height of it. Any question on how we got the height to be 1 out of 30?
You don't simplify it, it just stays like that.
Yeah, you just leave it as that. You don't really want to simplify. When you say simplify, you mean like turn it to like a decimal?
Mm-hmm.
Yeah, like it'll probably be easier if you just leave it like that.
Okay.
Okay, so from 10 to 15, what's the difference between 10 to 15?
5.
Yeah, 5. So that means I know the base is 5. I know the height is 1 out of 30. So in order to do this, we're going to multiply. So if you multiply, you get 5 times 1 out of 30, which is equal to 5 out of 30. So then if we go to our calculator, info, share the room. So if we do this, we'll say 5 divided by 30. So, and you get, well, 0.1666666. So that means everybody should have chosen C. And that's your answer.
Aha, I got it right, I guessed.
Cool. Good job on guessing. All right. Everybody good for that?
Yes.
All right. So let's scroll down, and this should be the last thing for today.
Yay!
So for this one's an example of a normal distribution. So this is technically something we already did. So for this one, say if we look at the height of all young women, we find that they closely follow a normal distribution with a mean of 64.3 and a standard deviation 2.7. So this is telling us N is 64.3 and standard deviation 2.7. So that means this is mu, this is sigma. Everybody go with that mu and that sigma?
Yes.
So if you remember, whenever they say a normal distribution means it should look something like this. So that means in the middle, you always want to put 64.3. So that's the mean always go in the middle. So if you look at this one, they want to find the probability that a randomly chosen young woman has a height of 68 and 7, between 68 and 70 inches. So we're going to say 68 is over here and 70 inches is over here. And if you look over here, it says between. Between means it has to be in the middle. So we want to find the probability of this area right here. Any questions so far on how I got that shaded area?
No, because it tells you.
Yeah, totally. Okay. So right now, if you do have Class Calc, you should take out Class Calc. We're going to be using it in a minute.
I didn't get a copy.
Here, let me take this out.
Thank you.
And if you are using Class Calc, make sure that you have it in graphing mode. If it's not on graphing mode, you're not going to be able to do this.
Okay, let's go to graphing.
And just to double check, this is on YouTube, right? Just in case we have to come back as a reference.
Yeah, it's not right now on YouTube, but yeah, I will post it on YouTube like I did. Cause you saw the first lecture that we did. It's on YouTube.
Yeah.
Yeah, I'll do that today. But yeah, so later on today it should be on YouTube, and I'll upload the link on Blackboard.
Okay, I was just double checking. Thank you.
Okay. Let me just log into this. All right. So what you want to do, if you're in ClassCal, once you have it in graphing, go to Stats.
Mm-hmm.
And what you want to make sure that you have it is you want to go to Advanced.
Okay.
Oh, sorry. You want to go to Distribution. So click on Distribution. Sorry about that.
Mm-hmm.
Everybody that normal distribution?
Yes.
So right here, what you want to do, you want to click right here where it says Normal Distribution.
Mm-hmm.
And if you look at the first thing that it wants you to tell it the mean. So if I go back over here, the mean is 64.3. So
Mm-hmm.
I'm just going to enter 64.3. Now the second thing that it wants the standard deviation. So you say standard deviation is 2.7. Everybody good so far on normal distribution, putting in the mean and the standard deviation?
Yes.
Okay. So then what you want to do, you want to hit CDF because we want to find the probability. And if you look at it, it's telling us what's the lowest number, what's the highest number that gets shaded. So by looking at the red area, what's the lowest number that gets shaded?
68.
What's the highest number that gets shaded?
70.
Yeah. So we'll say 68 to 70. And if you look at it, it'll give us the probability. So it says 6.79%, or you could say 6.8%.
Cool.
All right, and that's it for that one.
Oh, cool. Yay.
Question on how to do that problem. Okay, so if you do have a TI-83 or 84, I'll show you how to do that on the TI-83 or 84. So if you do have a TI-83 or 84, take it out. All right, so for the TI-83 or 84, you want to hit the second button. So you hit second, and then you go right here where it says distribution. Everybody good so far with that first step for the people who have the TI-83 or 84?
Yes.
All right. So if you look right here where it says normal CDF, you want to enter normal CDF. If you look at it, it's asking me for the lower. So the lower will be my 68. So put 68. My upper is just the 70. So you put 70. If you look at it, it's asking for mu. Mu is 64.3. There you go, 64.3. And lastly, is asking for standard deviation, which we have 2.7. If you go all the way down, you press paste and you hit enter one more time. And if you look at it, it'll give it exactly the same answer that the class calc gave us. And that's how you deal with the TI 83 or 84. Any question on how to use it with the TI 83 or 84?
No.
All right, sweet. So we're gonna go over one last section and that's it. Okay, so for 12.7, you're talking about random variable. Whenever we're talking about random variable, we're always talking about the x variable. Because the x variable, we could set it equal to any number. So we could set it equal to like 68, we could set it equal to 7, we could set it equal to 100. So whenever we talk about random variable, we're talking about the x variable.
Okay. Random variable is like x.
Correct. Because if you kind of notice when I go like probability that x is equal to 3, I'm just saying x is equal to 3 because x is our random variable and x should represent any number.
Okay.
And then you have the probability distribution. So the probability distribution is just a random variable that tells us which value can take and how to assign a probability to those values. So the probability distribution is the same thing as saying probability model. So if you remember for that one, we checked the two conditions that had to be between 0 and 1. And the summation of those probability should add up to 1. So when we're talking about probability distribution, it is saying we have a table, and that table is listing all of the probability for all these different outcomes.
Okay.
Whenever we're talking about a finite random variable, a finite random variable just means that we can actually count how many outcomes are possible.
Okay.
So say like when we're rolling a die could equal to 1, 2, 3, 4, 5, 6. So I can actually list out all the possible outcomes because finite. Something that's not finite is continuous data set, because continuous data set just means there are infinite many options or infinite many outcomes. So if I tell you how many outcomes are there from 1 to 2, if we're counting decimal, essentially you're gonna have infinite many answers. Because from 1 to 2, I could go 1.1, 1.2, 1.3. But then there's also a number in between 1.1 to 1.2, which I could put 1.11, or from 1.2 to 1.3, we could say 1.21, so forth. So whenever we're talking about continuous, there's infinite many outcomes. If it's a finite random variable, that means you can actually count how many total outcomes there is. They're not going to be infinite many outcomes.
Okay.
Cool. All right, and that's it for the lecture for chapter 12. Any question for lecture for chapter 12?
No.
No.
All right, so what I'm going to do, I'm going to show you where you need to go to take your quiz, which I'm going to open up tomorrow. And I'm going to give you all the way to Sunday to do the quiz. So you can take it whenever you want, from Friday all the way to Sunday.
Okay.
All right, so let me go to Dominguez. So for this one, in order to go to the quiz, you want to click right here where it says content. And then the quiz should be right all the way here in the bottom. It should say quiz on chapter 12. If you look at it right now, it kind of like, well, it's not, it doesn't have the color right now because it's not available. It'll be available for you tomorrow.
Okay.